All right, so now let's talk about vision. And vision is really important when it comes to flying because it's responsible for 80+% of all the information that we receive during a flight. And our eyes are really amazing sensors. Learn about the eye if you have not done so before. They're amazing design sensors, but they do have limitations. And so we need to be just aware of those limitations so that we can properly account for those limitations when we're flying. Here's just a diagram of what our eye looks like. The back of our eye is covered with photoreceptors, photooptical sensors, and you can see the distribution of those sensors. We have two types of sensors, and they are called cones and rods. The cones are centrally located. They're right on the back side of your eye compared to where your lens is. So here's the lens in the front part of your eye. That's where the light comes in, and the cones are directly behind that. So we have most cones right in the center. And those cones are going to be what you're using when you're focusing on things. So you're focusing on the screen, you're focusing on a page, you're focusing on your drone in the air. That's going to be using the cones. The rods are going to be off to the side. And you'll notice we have a blind spot here where there are no receptors. And that's shown here. That's where the optic nerve goes to the brain. And what happens is our sight, our vision actually happens in the brain. So we see with our brains. We don't see with our eyes. And what happens is our brain actually acts like an image processor, and it fills in the blind spot. So even though both of our eyes have this blind spot, if you cover one eye, you won't see that blind spot because your brain fills in that spot with the surrounding area. So if we look at this diagram, again, the center part of our vision, the area of best day vision, is what the cones are going to be used for. The rods, though, are low light, used more in low light conditions. They're 10,000 times more sensitive to light than the cones. And during night vision, you're going to need to use your rods in order to be able to see, because of where your rods are placed on the inside of your eye, they're around the outer edges here, you're going to need to use your peripheral vision to see at night when you're flying at night or when you're just trying to look around at night. That's going to be your rods which are more sensitive to light. And you can try this out on your own. So you can go home at night, if you're in your room, close the door, turn off the lights, and wait for about 15-20 minutes. Actually, it takes several minutes for your eyes to adjust to the dark. Your cones are going to adjust within just a few minutes, but they're not going to adjust very much. And your rods are going to take much longer to adjust, but they're actually going to become much more sensitive to the small amount of light in a dark room over time than the cones will. So the cones will adjust quickly, but they won't adjust very much. The rods will take much longer to adjust, around 25 minutes actually, to fully adjust to the dark, but they're going to be much more sensitive to light coming in than the cones will get to be. And so that's why when we're viewing things at night, our area of best night vision is going to be around the peripheral of our vision. So again, you can go to your room, turn off the light, close the door, wait for your eyes to adjust, wait that 25 minutes or so for your eyes to adjust, and then just look at, if you're trying to look at something, see how you need to tilt your head slightly or use your peripheral vision to be able to see that the best way possible. And this actually leads to something which is the best way to use your vision to maximize your situational awareness, and that is through scanning. Scanning is the best way to maximize your situational awareness during flying because it allows you to sort of use both the direct vision as well as your peripheral vision to the best use possible. And there's actually a kind of algorithmic way to do this. The best effective scanning is to scan from right to left or vice versa and start at the greatest distance and move inward. Scan 10 degrees at a time in 2 to 3 second intervals, and that's going to maximize movement detection. I didn't mention this, but your rods are also very sensitive to motion. And so you'll be able to take that to your advantage. And here's a diagram which just shows how this works. So you're scanning the sky. You're not just staring directly at your drone. You're not just staring directly at your controller. You're scanning the sky starting from the left, scanning in 10-degree increments every couple of seconds, to the right, and then moving from far to close. And you're just going to repeat doing this over and over again. And that's going to allow you to maximize your situational awareness, be aware of movement in the sky. So night flying used to require a waiver, but does not anymore, and it can now be done by anyone who's received the proper training and follows the regulation. So if you pass the initial knowledge exam after April 6, 2021, you don't need to be able to do anything else to be able to fly at night. Your UAV must be equipped in order to fly at night with anti-collision lights visible from 3 statute miles. That's the big requirement. If you're going to fly at night, you need anti-collision lights that are visible from 3 statute miles and flashing. And the same requirement, whether you're flying at night or during civil twilight, same requirement applies, and then you can fly. But in order to fly at night, you're going to need to be aware of these things that we've been talking about. You're going to need to help your dark adaptation by avoiding bright lights. So you can do things like wear sunglasses if you have to go into a bright building. Turn down the display on your controller before you get to the field, or use a red or green flashlight to help avoid resetting your dark light adaptation. So it takes that 25 minutes for your rods to adjust to the dark, and if you go into a bright light situation, that resets, so you'll have to wait another 25 minutes in order to readjust back to the dark. And make sure not to blind people around you. Because nighttime operations can be more fatiguing and stressful, you're going to need to make sure that you're on top of your game if you're flying at night. You'll want to be 100% energy level and be fully aware of what's going on around you, be able to communicate with your team when you're flying at night. And there are a number of illusions that are specific to flying at night. The picture on the right is not one of those illusions, by the way. This is just a really cool light painting picture that I found online. These light painting photos are really, really cool, and they are done with drones. So check some of those out. Do a Google search online. Look for light painting at night with drones. You'll see some really cool pictures. So perception at night. During the day, we have lights and shadows that sort of allow us to discern distances and allow us to kind of keep ourselves oriented. And when it's at night, these extra clues are missing and objects appear more uniform. This is especially a big deal if you're flying in an aircraft, for example, but it even can be an issue with drone flying. And there's 4 types of illusions we'll mention right here: autokinesis, false horizon, reversible perspective illusion, and flicker vertigo. So autokinesis. This occurs when you're staring at a single bright light in the distance against a dark background, and it can look like the light is moving, and it's a little bit of an autofocus problem. What's the solution to this? Scanning. Don't stare at a light, don't stare at your drone, don't stare anywhere, but scan, move your vision back and forth, doing that scanning motion that we talked about earlier. That's going to prevent this from happening. There's also a false horizon, and I'll put the bullets up all together here. Kind of a gravity hill kind of illusion. That just means that the actual horizon can be distorted, and it can look like there's a different horizon, and this can result in a what appears to be a tilted horizon, and it makes you lose your orientation. And again, this is going to occur mostly when you're in the air, when you're a manned pilot. But it could happen during UAS flights in areas where you're up above, up high, and you're able to see lights on the horizon. The reversible perspective illusion is what happens when an aircraft that appears to be moving away from you is actually moving towards you. And this is just, again, a night perception. It's difficult to counteract that perception, but what we can do is we can use lights on the aircraft. Lights on an aircraft tell us what's actually happening. And let me just pop up the picture of the aircraft I have here. So here is what lights on the aircraft, and this is all aircraft. Have this light arrangement, all manned aircraft that is. The forward-facing lights are going to be green on the right, and that's the one that I can always remember, green on the right, and then red on the left, and then white if you're facing the rear. So if you see white lights and you see green on the right, red on the left, that aircraft is going to be moving away from you. On the other hand, if you see green on the left and red on the right, you see those lights, that means the aircraft is coming towards you with the green on the left. Because that means it's facing your direction. And then finally we have flicker vertigo, which is where flashing lights with a particular set of frequencies can produce nausea and vertigo. And again, the key here is don't stare. Don't stare at any lights, including your drone. Use proper scanning techniques in order to maintain that situational awareness, and that's going to keep a lot of these things from happening. So just general tips for flying at night. Planning. Flying at night is not the same as flying during the day. There's more things that can go wrong. If you lose sight of your drone, what are you going to do? You can't use the camera on your drone to tell where you are, so you're going to have to do something else. You're going to have a better, definitely you're going to have a contingency plan in place to know what to do if you were to lose sight of your drone, or if you were to lose control of your drone. What is going to happen? It's going to be much more difficult at night. Make sure that you check your strobe lights, make sure that they're charged before you go out to fly, and make sure that you have a backup. Know the obstacles in your flight area. Do a pre-flight check during the day or a pre-flight walkthrough during the day if possible, so that you know where all the obstacles are. And if there are landmarks around which are lit up, make sure you know where those are relative to where you are and can use those as kind of markers to tell where you are and where the drone is. Make sure you set that return to home function on your drone appropriately, especially the altitude. So again, you're not going to be able to use your camera. You need to make sure that your drone knows what to do, is properly programmed to return to home in a safe way if you are to lose signal. Sometimes it can actually be helpful to add more lights. For example, green and red lights in the same configuration that aircraft use so that you know which direction your drone is facing. And that can also help in navigation. Use visual observers if needed, and you're going to need to do this especially because you have to avoid flying over people. So if you're flying in an area at night where people are, you'll want to avoid flying over them, and so you can use visual observers to help you with that. You can also use visual observers to help you watch out for other aircraft. If you're flying near an airport, you should know if the tower is closed or not and what frequencies to monitor, typically the CTAF frequency or the control tower frequency if it's a very large airport, and that will all help you maintain your situational awareness. Now, let me just go ahead and put these bullets up. If you lose visual line of sight at night, this can be very traumatic and possibly dangerous. It could mean that there's an obstacle to your vision, which obscures the drone. It could mean the drone has entered fog or clouds, and that could be very dangerous because those can build up quickly at night, and if there are other aircraft in your vicinity, that can really be a problem. And then it could mean your drone has crashed. Maybe there's a hill in the distance. Maybe you didn't know about that hill, or you didn't do your pre-flight walkthrough, and you crashed on a tree or on a hill or on a tree on a hill, for example. So what are you going to do? First thing is to stop. Stop the drone immediately so that it doesn't get farther away. Stop moving the drone, and that will allow you to sort of take stock of the situation and respond appropriately. Verify whether you still have control signal from the drone. So if you're able to control the drone, if you're not able to control the drone, then hopefully you've set the return to home functionality correctly. If you still have signal, then you can do things like climb until you see the lights from the drone. And again, if safe and legal, you can climb up to 400 feet, get it up above any obstructions. Now, if you're up in fog and clouds, or if you're up in if you are in clouds, climbing is not going to help. If you've gone into a cloud, what you may have to do is decrease your elevation. But again, you want to be very careful about obstructions and hills and trees and things like that in the area where your drone is. Now, if you have a visual observer, you can have them try to walk towards where the aircraft should be. So in other words, if you walk closer, you can listen for the drone to see if you can hear it. If you can hear the drone, then you at least know approximately where it is, and you can use that information to get the drone back to where you need it to be. And return to home. If you've got control, you can tell the drone to return to home. Maybe the strobe lights have failed, but you still have a connection. And so in that case, the drone can just come back and you can replace those strobe lights. Just a few notes about strobe lights. They must be visible from 3 statute miles. You can use any color or number of lights. There's no special requirement from the FAA. If you want to use colored lights, I recommend that you use red and green in the same configuration as manned aircraft. And that way, not only will you be able to see the aircraft, you'll be able to know what orientation it's facing. And you can do the same configuration with red, green, and white lights that the manned aircraft are using. And also other aircraft will potentially, if they see your drone, they'll also be able to know what that is. Now, if you're doing a night flight in controlled airspace, really there's not going to be any difference for controlled airspace flights at night versus during the day, except for the fact that some airport towers are going to be closed at night, and the airspace may revert in that case to uncontrolled airspace, or it may revert to a lower class of controlled airspace, in which case you just need to be aware of what that is. You would still submit your requests via the LANC or the FAA drone zone, depending on the situation, and you don't need any additional clearance once you have that LANC authorization. But it's really, really important to clarify when that airspace is controlled, and to do that, what are you going to do? You're going to look at the chart supplement. Well, look at the charts, identify the airport, look at the chart supplement, find out when that control tower is active, and also the Before You Fly apps can also help you with that. But make sure that you check the chart supplement because that's going to be the definitive source of information for that airport. So here's just an example. We've got the Waynesville St. Robert Airport, and it's going to be active You see here the star near the control tower tells you that this airport is only going to be active part of the time. That control tower is going to be offline for part of the time. Here's where you would have to go look up the chart supplement to see what those actual hours of operation are and what the airspace becomes once that once that control tower goes offline. And here's that information taken straight from the chart supplement. Airspace, Class D, service, SVC, service is from 1300 to 400 Zulu time. So that's UTC time, so 1300 to 400 UTC time, Monday through Friday, excluding holidays. Other times, Class G. So this airspace is actually uncontrolled airspace outside of this particular time interval and outside of Monday through Friday. So if you're flying on a Saturday, for example, uncontrolled airspace, you don't need to get LANS authorization to fly. So it's important to clarify when the airspace is controlled, particularly when flying at night, because the apps do not always show the airspace classification correctly. Now, one thing to note is if a Class E4 airspace is attached to a Class D airspace, the Class E4 airspace is those, actually we had an example here. Here's our Class E4 airspace. It's attached to a Class D airspace. If the Class D airspace reverts to Class E off hours, the entire airspace becomes Class E2, including the airspace that would ordinarily be classified as E4. So this is a little bit of a technicality, but just make sure that you're aware of that, what happens there, and look at the chart supplement for that information about what happens to the class controlled airspace during off hours. All right, so that's it for this video.